Hello, boys and girls, and welcome to another episode of your favorite algorithm channel. Today we're going to be doing LeetCode 23, merge k-sorted lists. So on the screen here, you can see that I already have a function here, merge two lists. Merge two lists is the subproblem to the problem merge k-sorted lists, and merge two lists is a problem that we tackled in an earlier video. So I suggest that if you haven't seen that one yet, that you go ahead and watch that video first before tackling this one. But if you're already comfortable with the idea of merging two linked lists, then feel free to go ahead with this one. So with that said, let's introduce the problem. So merge k-sorted linked lists and return it as one sorted list. Analyze and describe the complexity. Well, we do that in every single video, but what we want to do here is we want to take an array that has a number of linked lists, any number of linked lists, and efficiently merge all of them and return them as one sorted linked list. So to do that, we're going to use the merge to list function as the subproblem to this greater problem. And as always, I suggest that you try to solve the problem first. And if you get stuck or you just want to see how I solved it, then go ahead and check out the video. So if you're ready to get started, come with me to the whiteboard. So on the screen here, I have drawn 6 linked lists. So we got 1, 2, 3, 4, 5, and 6. So these are our 6 linked lists. And the strategy we're going to use to solve this problem is at each iteration, so we're going to iterate over this array. And at each iteration, we're going to grab two of our linked lists, and we're going to merge them together. So effectively, we're going to be reducing the size of our array by half. And we're going to keep doing that until we get down to one item in our array, and then we're going to return that item as the answer to our function. Because once we have merged down to one linked list, well, that means that we have one sorted linked list, which will be the answer to our problem. So the way that we're going to do that is we're first going to take our first 2 items, and we're going to merge them together. We'll merge those together, and it'll give us our new linked list. And then we'll merge our next 2 linked lists together, giving us a new linked list of length 4. And then again, we'll merge our last 2 linked lists together, giving us another linked list of length 4. So now you can see that we have gone from 6 linked lists down to 3 linked lists. And we're just going to keep repeating this process. So we'll grab our next 2 items on our next iteration, merging those linked lists into a linked list of size 8. And because we don't have anything to merge the last linked list with, we're just going to pass it down to the next array. And then finally, we have 2 linked lists left. So we'll merge those final 2 linked lists into one linked list, which will be our answer. So that's going to be our new linked list of size 12. So what's the time complexity of this problem? Well, you can see that it took us, we're basically having the size of our array at each iteration. So if we look at the lengths of our array, so first we start out with an array of size 6 or length 6, and we go to an array of length 3, down to 2, and then finally 1, where we can return our answer. So it's not exactly half, but it's about half, right? We're doing kind of bucket math here. We're reducing the size of our array by about half at each iteration. And what are we doing at each level? So at each iteration, well, we're basically touching every single node each time, right? Not every time, right? Because here you can see that we've just passed that linked list down, so we didn't iterate over those nodes. But we can say that it's bounded by the number of nodes that we have. In the worst case, at each iteration, we're going to be touching every single node. And we'll call that k. So that's k nodes. So what's the time complexity of this problem? Well, it's going to be k in terms of the number of total nodes that we have, log n in terms of the length of the array or the size of our input array. So now that we have a better idea of how to solve this function, let's see what it's going to look like in code. So as you can see, we have our merge to list functions here, function here that we are going to use that we wrote in a previous video. So I won't go into too much detail now about how that works. So let's talk about how are we going to do the main functionality, the merge k-list function that we have here. Well, the first thing we want to do is we just want to check to see if our array is empty, because if our array is empty, so if the array length, if not array length, if not array length, well, then we can just return null because we don't have any linked list to merge, so we don't have anything to return, so we'll just return null. So that'll take care of the edge case where we have no linked lists in our array. And then we want to we want to keep looping. And how long do we want to keep looping? Well, we want to keep looping until the length of the array, while the length of the array is greater than 1. If the length of the array is greater than 1, well, that means we still have some work to do. We still have some linked lists to merge, and we want to keep merging. And so while we're looping over our array, what do we want to do? We want to reduce the size of our array by 2. We want to take 2 lists in our array, and we want to merge them together. So I'm going to create a variable called next, which is just going to be the next array. And I'm going to use this to push our merged linked list into. So we need to loop over our array. So we'll let I be 0. So I be 0. And while I is less than the length of the array, we'll increment I. And how do we want to increment I? Well, I is going to we're going to increment it by 2 because we want to grab 2 indices at each iteration or at each stage in our iteration, right? Because we want to grab 2 lists and pass them into our merge 2 list function. So we want to push the result. So we'll push into our next array the result of calling merge 2 list with the input of the linked list at array I and the linked list at array I plus 1. So that will grab our 2 linked lists. In the case of an odd numbered array, array at I plus 1 will just be undefined. So when we pass undefined into our merge 2 list function, well, we're just going to end up returning the linked list that is defined. So if L2 in our merge 2 list function is undefined, then we're just going to end up returning L1, and we've already taken care of that logic by the way that we wrote our merge 2 list function. And now that we have written the logic for reducing the size of our array by 2 by merging 2 linked lists at each iteration, well, we want to then reassign the array to be the next array. And then at the end of our function, we just want to return the first item in the array or the only item in our array. So let's do a quick recap. So in our merge 2 list function, we're taking in 2 linked lists, and we're just assigning a pointer to point to the head of our new linked list, or not our new linked list, but the linked list that we're going to be merging together. And then while we still have nodes in each of our linked lists, we're going to iterate through it. We're going to assign, we're going to append the next, the value, the lesser value to the end of our linked list. And then we're just going to reassign the head. And then at the end of our iteration, we're just going to take head.next, and we're going to append any nodes that are left over. So if L1 still has nodes left over, we'll attach that to the end of our linked list. If L2 still has nodes left over, we'll attach that to the end of our linked list, and then we'll just return the linked list at the end. In our merge k-list function, we're just checking to see if there are any linked lists in our array. If there are linked lists in our array, then we want to do the logic for merging our linked list. Otherwise, we'll just return null. And then here, while the length of our linked list is greater than 1, we're going to keep doing our work. And we're going to define a next array, and then we're going to iterate over our array, taking 2 indices at a time, merging them together, and pushing them to our next array, and then just reassigning array to be the next array, and returning the first item in that array at the end of our function. Okay, looks like I've got a typo here. Merge 2 lists, not defined. So it looks like I have a typo. Okay, yep. Let's try that again. Okay, great. Let's see if we can take a look at the distribution. Okay. Well, so the link to the distribution is currently down. I did run this function a few times to see if I could get access to it, but it looks like they might be doing some work right now. But anyways, there are actually a lot of different approaches you could take to this problem, and I'm toying with the idea of doing another video where I solve this problem in a different way because I think there are a lot of interesting ways to solve this problem. But this is basically a sorting problem, right? And the best we can do in sorting is n log n. So the different ways we can sort are quick sort, merge sort, and then also there's heap sort is another way to solve this problem. So that's the way you would solve this problem using heap sort is with priority queue. I think that would be a fun way to approach this problem. So stay tuned. I might do another video where I solve this problem using heap sort. But for now, I hope you enjoyed the video. I hope to see you in the next problem, and I hope you learned something.